Hello, everyone. Again, welcome to track 2. And like I was saying earlier, Pedro is not going to be able to make it today, but we have Kris Wall that's going to do an introduction to web application security. And Kris is one of our B-Sides organizers. He came in just this last, couple years now, but been a heavy hitter. I mean, if you see the site, you can blame Kris Wall for that because it's so beautiful. I've fallen in love, honestly. Okay, so I'm going to stop. Some admin items again. Lunch, if you haven't done it, go ahead and go to Uber Eats, and you can actually find that at tiny.si/BSOK, or to go ahead and get your Uber Eats, I guess, voucher. And so that's about $15, I believe, $15 voucher for Uber. So we're trying to get your lunch today. Again, Slack, we have a Slack channel open if you, probably how you got to this video. And then swag, update your Eventbrite registration to go ahead and make sure you do get the swag, which includes a shirt and maybe some other paraphernalia that we may be able to send out to you. And finally, there is a Capture the Flag event going on, and it's a world-class event. You can find more details over at BSidesOK-CTF channel in the Slack.Techlahoma Slack channel, I guess you'd say. All right, so I'm going to go ahead and release the mic to my good friend Kris, and he's going to go ahead and do the introduction to web application security.
All right, guys. My name is Kris Wall. James, definitely thank you. We're actually looking at each other, but James, thank you for the intro. We did have a speaker that was lined up, Pedro. He is out for some family items, so I'm going to fill in with a familiar talk for some of you guys. You guys know that I am deeply focused on application security, and I'd like to go ahead and give that intro to application security, and hopefully, guys, as I'm continually learning new pieces, that there'll be some valuable pieces in here for you guys. So we're going to go ahead and share our screen. All right. One moment. All right. There are a ton of slides, and we're going to do our best to make it through all of these today. So it's going to go fast. Here we go. All right. Okay, guys, welcome. Thank you for joining me for application security, or intro to application security. I recently picked up my own little Twitter handle. I've had a couple of the years. Kudos to those who can find them. But I'm going to start joining the greater course in Discord, folks that are in Twitter, and be able to contribute more of my own research and have you guys help jump in with my own research. So, a little bit about me. I work for a company called Stinnett Associates. We actually just did a plug over in track 3. You might have gotten to hear from Jeremy Price. He's one of the individuals over there that has helped me build out this new practice. Before that, I worked for True Digital Security, some great folks over there that provide security testing services as well as full IT services. So they're a really great group over there. Before that, I was a freelance developer. I spent a couple years doing web development myself, and even before that, I was in the realm of IT for well over a decade. So I've been around the block a couple times. This is definitely not my first rodeo, but out of freelance developing, when I spent that time doing that, I became obsessed with fixing the bugs that I introduced to my own applications. I wrote a lot in PHP, a lot of Java, and wrote web applications and made a lot of mistakes, a ton of mistakes. And I thought I was really bad at programming with how many mistakes I was making. So it became an obsession to fix these things. Little did I know, I thought I was a bad programmer. I'm pretty much middle of the pack. That we're all fairly bad programmers. None of us are absolutely perfect with bug-free code. And I learned this over time, but out of the obsession of fixing these issues, became a career, and I was able to turn this into a passion and to something I can continue doing today. So now I know this intro to application security, that includes web and mobile and APIs, desktop server. So you guys can read, but we're gonna cover a little bit of everything there. as we go forward. So more and more mobile applications look like web applications. Desktop applications are doing more communications to the web. So you're going to see the same technologies, the same pieces of software and communications that are going across for web applications that are happening in desktop applications, even including servers. Okay, so we're going to go kind of fast here. I really need to get you guys started with a couple of these pieces. Okay. So there we go. We'll fix the mic. Okay, so we're going to go pretty quickly here through a couple different pieces. And let's go ahead. And this is going to be quick. There's a lot to cover. And hopefully most of you are fairly familiar with a lot of these pieces. Okay, so anatomy of your URL. So it's important to understand that we have protocols, we have the domain name, we have the ports, we have the paths, parameters. So this is where you have the question mark and you have the key value pairs. And then finally, we have anchor tags. So the anchor tags there at the bottom right, that's where it's important to know once we have an anchor tag, at that point, we're no longer talking to the server, we're talking to the web page itself. All right, so here's a brief anatomy of an HTTP request. This is the basic request that is used. So over here on the right, you can see that we're communicating with HTTP 1.1. We are, HTTP 2 is available with 3 on the way. We're not going to cover those. HTTP 2 is not widely adopted, and it does some funky things. It was trying to build security into the protocol, and HTTP 3 is making a great leap forward. But today, the vast majority of applications rely on HTTP 1, and we're going to cover that. You have to have 2 headers. You have to, at the very minimum, you have to have a GET, and you say GET, in this case, the root, and then you have the host. You have to say, what are we asking for? HTTP 1 or 1.0, you didn't actually even have to have the host, but in this case, HTTP 1.1 wants that host information. If you hit a website that has multiple, or a server with multiple websites on it, you need to specify which application you're trying to talk to. I'm sorry, which website you're trying to talk to. And the body is always optional. Okay, so we have a couple different verbs. So in this case, we have a GET request. So we are getting the root, but we can also post. So when we get, we're retrieving a record. When we post, we're submitting a record. So that is the time when we're trying to actually update our information. And you will see there are developers and teams that flip-flop these sometimes, and you really should stick to this paradigm. But it's important to know that that data can be sent through a GET request, and it's important to understand that when those resources are updated that way, that may be a finding in of itself. All right, so we have a couple others. Head, and we'll be brief here. Head is where instead of asking for a resource and retrieving it, you just say, is it there? So this is actually a very valuable piece when you're running a directory search. You're looking for folders and files. So if you're starting a pen test of an application, you can do a bunch of head requests, and you can give it this huge list of head requests. And now a development team or a blue team may see this, and that's something they can block because this is attempt. Nobody should be asking for thousands of head requests. That's a good indicator that something's up. But it's very helpful for us to be able to see what's there without actually transmitting. If a 1 meg file is there and there's 1,000 of them, I can do a head and never transmit any of those files. Where if I did a GET, I would get all 1,000 files at 1 meg, just eating up a ton of bandwidth there. Put updates a payload. I'm sorry, updates a record. Deletes a record. Connect is actually what we use for HTTP proxying. The options is actually what the verb that we use to see what other verbs are available. The server will respond back. Yeah, these are the verbs that I support. And trace and patch are some of the weirder ones that you'll see very rarely. Okay, and in a request, there's always 2 halves of the request. You have the request headers, and you have the request body. Those pieces, the body may be blank. There may be nothing in the body, but the body is still there. That's a very important piece. So oftentimes you'll have cookies. This is where a lot of credentials are stored. Tokens are stored. Information that needs to be remembered is typically kept here. Okay, so, and as we're going through the anatomy, I'm going to cover a lot of these pieces. And it's important to know that they're there. So then we come back through and the vulnerabilities that we're going to discuss so you understand what exactly we're attacking. URL has parameters. So once again, the question mark and the parameter name, so name, and then whatever it equals, so the value. Here, we also have user agent strings. And the user agent string is what we're using to identify ourselves. This is an interesting spot that web servers will respond differently to different, well, more specifically, applications will respond differently to different user agents. For the most part, they respond the same to every user agent. But if a Google spider comes across, the Google bot or any of these other spidering bots come across, sometimes they act a little bit differently and they'll give different information. And when you're doing application security testing, this is one of the things you want to look at. Is there any information disclosure that we can find through the user agent by changing that? Okay, so when you send a request, you're going to get a response. Again, this is communicating on HTTP 1.1. And one of the things we really want to look at is that content length. If you see here, about in the middle on the right side, it says content length 1925. So that's an important thing. They need to tell us how long the content is. Otherwise, we're not going to be sure if we got everything. Without receiving the full content length, then we may not get all the information. Again, this is one of those things that changes a little with the other HTTP protocols, protocol versions. And that's an evolving piece that I'm sure it's going to have some new and interesting security implications. We have HTTP codes. There's a much more vulgar version of this on the internet, but essentially when you request for something and you get a 100, like a 101, a 100 request, it's saying, I got you, I'm doing something. A 200, any kind of strict 200 or 201 tells you, yeah, you're good, it was a good request. 3 means you did something wrong, or the resource is no longer there, or we're going to block you and redirect you somewhere else. So it's basically the go away. Any 400s, that means that you screwed something up. You sending the request made a mistake. And 500s, which as an application pen tester are my favorite, those are the places where the server screwed up. And we really want to look into the places where mistakes are made. Okay, so there's 2 pieces to the response. It has to have a header. And it's going to have a body. It could be blank again, but the body's always at the bottom. And if you notice, there is a space right here. That's very important, that there's always a space between the headers and the body. In the request, that's also the same case. If you try to send your request and you're missing that, you'll actually watch as the request never fully completes because the server is still waiting for you to send more. Okay, again, we have cookies. It's going to set these cookies. So before we showed where we were sending cookies with a request, in this case, the server is coming back and say, okay, that's cool. I'm giving you some new cookies. You need to hold on to these. And those cookies are going to have flags, and we're going to talk about that here in just a little bit. All right. The server can respond back with media files. If you look here in the where are we? Content type, it's about line 10. It says content type image. So it's a JPEG. So everything starting line 15 should be the contents, the binary contents of a JPEG file. It should be. That doesn't mean it necessarily will. And here we can also receive scripts. It's almost always JavaScript files. And these have, if we look here on line 10, it says the content type. So we're sending over JavaScript. And on line 16, we can show where we're actually filling that in on the body. Okay, so the DOM. The DOM is a weird concept. It's a good concept. The DOM is the document object model. And really what it means is, in its most simplest terms, it is an object created in JavaScript that we can interact with. And every time you go to a page, even if it's a blank page, even if there's nothing there or just a hello world, you technically have a DOM. It's there, your browser has created it for you. Firefox, Chrome, Edge, they all do these. They all have this DOM created. And if you look down here, right about the middle, there's a cookie. So we're in the document, and one of these attributes is the cookie. And there's other attributes. There's the information in the body. There's the background color. This is information that is stored in the DOM that was retrieved and built out for us. So this is important. The DOM is a living, breathing object that we can interact with. And that's an important concept that we're going to come back to. How it all fits together. So HTML, typically nowadays, just a bunch of div tags with some CSS thrown on top. That makes it, gives it a nice shape, some nice pretty colors, puts everything where it belongs, and then JavaScript to give it a brain, to make it function, to actually do things. Okay, so we have 10 basic vulnerability classes that we need to talk about, especially when we're doing any kind of application security work. So in order, or in alphabetical order, we have auditing and logging. This is important. Now, this is a non-functional requirement. What do I mean by that? A functional requirement is if I have An image sharing service, a functional requirement is you must be able to upload an image, as an example. The auditing and logging is not absolutely required for the image sharing application to work, but you need to have the auditing and logging because we need to have insights. We need to have these metrics of what is going on, so we know if somebody's trying to abuse our services. Authentication, and the next one, authorization, are two different pieces. It's important to have this understanding. Authentication is when I come to you and I'm going to buy liquor, as an example, and I show you my ID. My ID is the trusted ID, came from the state or federal government, and you review it and you determine if I am eligible or if I am who I say I am, and hopefully it has a picture on it. That's authentication. Who are you? Authorization is what are you allowed to do? So this is where if I am over the age of 21, then I'm allowed in the state of Oklahoma to buy liquor. So I'm authorized to do that. And you know, as I walk around the store, I don't need to keep authenticating myself. I don't need to keep showing my ID to everybody. That's an important concept. And applications do the same thing. Once they know and trust you because you've authenticated, then at that point you don't need to do anything special. Configuration management. This is anecdotally speaking, I would say 50% of all my problems exist in configuration management. This is where Ruby on Rails wasn't configured correctly, or the application server wasn't configured correctly, or the cookies and the flags weren't set correctly. And you know, these little things can add to bigger things. We can take advantage of little configuration mistakes. And the majority of my application pen tests find configuration mistakes that can be exploited. We have cryptography. This is an important thing. So anytime you have tokens, anytime you have information that needs to be kept secure, you need to be able to transmit that securely. You have to have strong cryptography. If you have weak cryptography or any weak entropy, then this is places where we can take advantage of that. And we'll get into that here in a little while. Error handling. I love errors. Developers don't love errors, but I love errors because it gives me some information. It lets me know what's going on behind the scenes and what can I do to break whatever you have. So it's important to also handle errors gracefully. Input validation. This is a very key piece to blocking certain types of attacks, such as injection, which is probably your biggest one. But it's important to have proper input sanitization on the back end. Oftentimes you see it on the front end. In fact, in this screen grab that we have right here, that's a front end input validation. But as many of you know, and I definitely know, is that I can take this information and I can send it directly to the back end, skip all your front end validation, and send you malicious payloads directly to your server. And you better have server side input validation that can block me or restrict what I'm allowed to do. Otherwise, I can send some really malicious payloads and take advantage of your applications. Parameter manipulation, a little bit different, a little bit of a bleed over back into input validation. But parameter manipulation is where we can send things that are unexpected. We can add parameters that don't belong. We can add parameters or duplicate parameters called parameter pollution. There's a lot of things that we can do to take advantage of that. And it's important that we handle our parameters and that they're handled correctly. And sensitive data. You don't want your web application leaking data. It's very important to make sure it doesn't leak at all. If it does leak, then you want to have the ability to find out what information, if I can get email addresses, if I can get internal IPs from the systems that are hosting things, if there are social security numbers that you thought were encrypted but really aren't, that there's ways of being able to see that information. And as we're working, we want to, especially as a pen tester, I want to catch that information. And finally, we have session management. So session management, okay, I've authenticated the application, I've been given a token, but there's still more to it. They have to remember who I am. And if anything changes about me, if I do anything special, then they also need to be able to handle my session and handle it well. If I change my password, my session should refresh, I should get a new session, or I should be forced to log out and log back in. There's something called session fixation, where I hit a website and you give me a cookie. I haven't even logged in yet, but you give me a cookie. Then I log in and I'm still using the same cookie. Aha, I don't even have to log in to get all your cookies, to get all your tokens. And what I can do is I can sit there and ask for thousands of times, give me a new session, give me a new session. And what I can do is I take this information and I can run statistical analysis on it and try to break whatever you're using to create your cookies or create your tokens. or I can exhaust your entire pool. And at this point, you'll start reusing them, and hopefully one of these cookies will actually work. All right, a little bit of extra terminology. We're going to go super quick. Web servers have caching. They communicate with the browsers, and they tell if the browser already has some information. There's encoding. Encoding and cryptography, or encryption, I should say, are two different things. I find it pretty often that developers will use encoding when they meant to use encryption. Or even hashing, that's perfectly fine. But definitely need to be aware that there's encoding, and we need to be aware when it comes into play. There's APIs. An API is an application programming interface, and these are on the rise when it comes to web applications. So they're a place where we can ask for information. We can hit it and we can ask, hey, give me this, and they'll usually respond in little one-liners or serialized data, whether it's JSON or XML, and they'll respond with this information, and it's important to know that's there. They respond with things like XML, which are these older SOAP applications, and you just need to know that SOAP is XML, and they might even respond with JSON. And they may even encode it, they may encrypt it, so it's important to understand what they're doing. We talked about the HTTP status codes, definitely keep that in mind. HTTP versus HTTPS, that's another important concept. We want to make sure that our communications are secure. To do that, what's that? I'm sorry? Oh, okay. Here we go. That's the benefit of doing it live. People come and pester you. All right, getting back on track. So HTTP is unencrypted communication, while HTTPS is encrypted communication, hopefully using a strong encryption suite provided by SSL or TLS. SSL, you really shouldn't be using SSL, but a lot of sites still use it. You should be really on one of the latest versions of TLS. SDLC, the software development lifecycle. Important piece to be aware of. These are the cycles that the developers follow as they're working, and a lot of mistakes are unfortunately made during this cycle, and it's important to catch those at every possible point, to have spots in the development lifecycle that catch these and fix them as they're going. And then REST. REST is a way of communicating with APIs, a way of communicating with systems where you communicate with a folder such as user/create, and then you send it some information for the new user you're trying to create, or user/login, or security/login, where you follow this. It makes sense. I'm talking to a user and I need to authenticate this user. I need to create a user, and there may be other services and resources that the REST interface will allow you to do. Okay, so we have a methodology. And it's important that we talk about this methodology. It's also important to know that no system is void of bugs. Junior devs a lot of times will think there may be one or two bugs, while senior devs definitely know there are plenty, and there are ones that we don't know about yet. Okay, so application security testing. So we have application penetration testing versus application security testing. It's important to know these are two different concepts. So applications penetration testing is essentially the application is running, and it's usually grouped in with other hosts on the internet, or other hosts within an internal network. And the idea is all security controls are left. Sometimes you're also measuring the response of the security team. So the security team may not be aware that you're performing your test. You need to have some sort of upper management be aware of what you're doing, but you're testing all the security layers at once. It's important to understand that's what application penetration testing, or just pen testing in general, is meant to do. And usually you're going against production systems. So these are important pieces to be aware of. But with application security testing, you want to remove those layers of security. Third-party layers of security. You want to test the application itself. If there's a WAF, a web application firewall, in the way, and it is interfering with your tests, you could get a false negative where you think, oh, I guess this machine's free and clear of SQL injections, when in reality you could have one on the box or on the application, and that nobody's aware of it because the WAF cleared it. Now, what happens when you update the WAF, or you change the security rules on the WAF, or you swap it out with a different one? At that point, you may reveal the vulnerability that was there all along that nobody was aware of. So it's important to be aware. These are almost always done in QA, and the difference is where a pen test, we find juicy targets, but we don't have the super luxury of time. Whereas application security testing, the idea is to walk through the majority of the application and to test the majority of those controls and inputs to get an idea of the attack surface and work our way through. So these are two different concepts. So today, we're going to lean a little bit more towards application security testing. These vulnerabilities will appear in both, but it's important to have that distinction between the two. I do like this. So we're like really advanced QA testers. We know that we can break things, and it's very likely we'll break things. And it's important that whoever you're doing this pen test is prepared for that. That they have, if it's production, especially if it's production, that everything's backed up, and that senior management has agreed to it and authorized everything. But if it's in QA, then it's okay to blow it up. It's not as big of a deal because you probably have less users, and it's easier to restore those things and not lose customers in the process. Okay, this is not a tools talk. I don't like doing tools talks. There are some tools you do need to have, tool types, but we're not gonna, I'm not here to say, go get this tool. Well, with one exception. But I'm not here to talk about the huge benefits of one tool over another. You need to have a couple tool types. Have to have an intercepting proxy. There's a ton available. Burp Suite, the Community Edition, and Pro work great. Pro works well if you're performing these in a professional capacity. Zap does a pretty good job. Of being right there, almost as good as Burp Suite Pro. And then there's Telerik, and there's a couple other man-in-the-middle HTTP proxies that can be used. But it's important because these intercept your HTTP communications, giving you the opportunity to inspect them, to alter them, and to send some interesting pieces directly to the application that operates outside of what the front end of the application was intended to do, but the server will still accept and respond to. So it gives us that ability to interact in ways that the developers probably didn't see us doing. Enumeration, you have to be able to see what's there. Generally, I like to spider. I like to spend some time understanding all the information that's on a website and finding all the hidden links and finding all the hidden content. Sometimes you don't get them all, and that's where tools like Darebuster and GoBuster and Derby, if that's your favorite, Derby, come into play, where they allow you to find hidden functionality, such as a /admin panel that didn't appear anywhere. Spidering is the act of hitting a page, going to every single link, hitting all those single pages and going to those links, while the Darebuster just says, I have a huge list of folders and files that I'm going to try to access. I'm going to go to every single one of these and ask if they're there and see what the server has to say. We may find some hidden functionality. Brute force, you can pick your tool. Hydra, there's a bunch of other tools that allow you to do this, but sometimes it may just come down to a simple brute force of username and password combo. You'd be surprised how often default information is left on machines, or debugging information, or test accounts. It's valid. It's a valid thing to go and test these to see if they're there. And sometimes you can even find some interesting backdoors, which has a little bit of bleed over back with the enumeration. So, but it's important to be aware of this. Application scanners. I am not a fan of application scanners. Automated application scanners. They have to be fine-tuned. They have to be really well fine-tuned and be able to explore the application in its entirety. And for the most part, they don't do that particularly well because they're trying to build a product that is a one-to-many, when in reality, we need a one-to-one relationship. We need application security tools that specifically target the applications that they're testing. Now, with that said, Nikto is an excellent tool. This is a tool that looks for known low-hanging fruit vulnerabilities. It has like a signature database of like 8,000 different items that it will go look for. And it will find, I mean, really, it saves you the time of looking for these things that are common and low-hanging, and allows you to work your way through these fairly quickly. Definitely, it is a tool that I would recommend using, that it works well in almost every case, but it's not gonna go through every application and actually try to understand what the application is doing. He's just checking for the low-hanging fruit. Okay, we need to talk about cookies. So cookies are almost always where your authentication information is kept. There are a couple other places that it could be kept, but cookies are pretty much the predominant ways of authentication. And I'm sorry, not authentication, but authorization, that you store these authorizing tokens. But unfortunately, they can be abused. And cookies work by, once you go to a website and it hands you a cookie, all your subsequent requests to that server will be sent with that cookie. So it's important to be aware of that. Yeah, GDPR, people stealing your cookies. But it's important to be aware that there's a lot here that's going on, and cookies have become a much bigger deal than they used to be in the past. A little bit about cookies. These are cookies from Google and their Gmail. And we can see that there's some tokens in here. So we have the SSID, we have the Gmail @ and there's some flags, such as we have these HTTP flags over here, which means if the HTTP flag is turned on, the JavaScript cannot access the cookie. That's important. Sometimes you do want JavaScript to access the cookie, but oftentimes if it's a very important cookie that you don't want people to steal, you want to say HTTP only. And in that case, it prevents a cross-site scripting attack, which is JavaScript, from stealing those cookies. And then there's a secure flag, which means that the browser should only be sending those cookies over HTTPS. If the secure flag is not turned on, then the browser may send it over HTTP. It's important to be aware of what is happening in the background. Again, this is what we covered here, but we can combine the HTTP only missing flag with cross-site scripting to be able to steal cookies. As you see in the bottom, I was able to pipe that out using JavaScript. In fact, it's right here in the URL where localhost index, and we looked here where it starts with the word index, A equals, and we have our script, alert document.cookie in script. That means I was able to steal the cookie, and here's the contents that were in it. Now, this is pretty harmless because it just pops up on the screen, maybe freaks some people out, but you could send it back to yourself. You could steal this information and be, especially with some simple JavaScript commands, send it back to another server, steal their cookies, and then come back and try those cookies while they're still valid. Okay, so let's get into all our vulnerabilities. Security is often more lax than organizations really want. I do appreciate when applications are being honest about their security, but it's probably not something that was going to make you feel good when an organization is admitting, yeah, our security is not so great. Okay, once again, we have our vulnerability classes. These are important when you're doing an application security test, pen test, whatnot. There are pieces you need to be hitting, and I've underlined them. You have authentication. You need to make sure that there's strong authentication. You need to make sure that once you're authenticated, that authorization is held true, that Bobby can't get to Sally's information and vice versa. Oftentimes that goes with access controls. And then you have session management that we talked about earlier. These are the key pieces that are almost always part of every single application. That are almost always there, and we want to make sure that those pieces are managed and tested every single time we perform a test. All right, so OWASP has their top 10 list, and the OWASP top 10 list is really designed to bring awareness to the top 10 most exploitable and most impactful vulnerabilities. I have a few issues with the list. I don't think that we have time today to really get into all the issues with the list. Remember, it is a popularity list. How they came out with that information is a little bit skewed, but I do agree that injection is the most impactful. It happens way too often, and it has way too great of ramifications. Injections, SQL injection, command injection, we'll get into these here in a moment. And I do apologize, we do have to kind of go quick. I do want to cover most of the slides as we're going through this. And there's these other pieces that are important to test, but they're less impactful than the top of the list. Better resources to use is the CWE, the Common Weakness Enumeration list. The top 25 is actually a really good list of places that you really should be checking when you're doing an application security test, places that you should be spending time in understanding, is the application actually secure? Then the OWASP ASVS, the Application Security Verification Standard, is an excellent resource that breaks down all these pieces in greater detail. It's meant to be used like a checklist. OWASP top 10 is not a checklist. These are just things you should be aware of. But the checklist you should walk your way down. In a pen test, it's a little bit less important to walk through all these, but in a security testing, application security testing engagement, you really should be walking through all of these as much as possible in regards to the application. So I love doing work with applications. I can make the front end super pretty, and you're totally unaware of just how gnarly it is in the back end. And when we're doing our application tests, I don't care about the front end. I mean, there might be some interesting things. I can interact with the DOM and make interesting things happen. Remember, the DOM is a living, breathing piece that can be interacted with, or you can switch to the back end. And that's where the majority of our conversation is going to focus around. So we have a few pieces we need to talk about. These are called attack vectors, insertion points, whatever you want to call them. It's important when we're doing our test, every application is going to have some combination of these that is able to communicate on. We talked about this before: parameters in the URL, parameters in the body, parameters in the cookies. We have the parameters themselves, the names of these parameters that we can manipulate. And we have the headers, the body, and then the URL file paths and folders, especially if we're interacting with a REST API. So these are places where you're going to be inserting your payloads, that you're going to be testing and trying to do detection methods to see if they work. All right, server-side attacks. We're going to go through these. I'm not going to read this list to you, but we're going to start with server-side attacks. There's a lot of them. We're going to go quick. We only have, I think, like 15 minutes left. So we got a little bit of time. So we may not finish this list, and that's okay. You guys are welcome to reach out to me. I'm here on the Slack channels. You can definitely reference me right there, or back on Cross-Site Kris via Twitter. Reach out to me. So hopefully we're going to make our way through this. We're not going to try not to rush these too much. Also, this is not an exhaustive list of application security vulnerabilities. This is a good cross-section of what we're going to be looking at, what you'll find out in the real world, but it does not cover every single type of attack. And I have no idea how long that would take us, but we don't have time for that. Application logic. You need to make sure. Now, this one doesn't seem like a security vulnerability, but it can do some really weird things, especially when you buy negative 1 million items and get that money added to your credit card account as a chargeback, or if you can buy their entire stock for 1 penny. These are some really big issues that you need to make sure, because they have financial repercussions, they have personnel repercussions. You need to make sure the application logic is secure. We're also going to cover a bit of the remediation of ways to prevent and information you can share with the development team. Yeah, use test-driven development. You know, run the checks, test for these weird cases, run your fuzzing on these to give it some really bizarre values and see how they respond. You need to have ranges. You need to make sure your type conversion is done correctly, and it's all needs to happen on the server side. Don't do these checks on the front end because they can be bypassed very easily. But here we have a quick example where we're sending a request, and I'm going to buy negative 100 items. And the application is that, sure enough, yep, success, great. You bought negative 100 items. You put them in your basket. Good luck. We have broken authentication. This is important. We talked about session fixation, which is we get the token before we even log in. No, you want to. Now, you can get a different token once you log in. That's fine, but they can't be the same token. If your tokens are weak, easy to guess, easy to break, then that's a problem because then I can just make up new ones. If I log in and I get token number 1, I'm going to try token number 2 and token number 3. And if you're hashing them, putting it like an MD5 hash, yeah, I'm gonna go check and see if I have that MD5 hash in a rainbow table or if Google has it, and I'm gonna try to log into your application with those because that's not good strong entropy. You can do bypasses. SQL injection can do bypasses. You can hijack, you can steal people's cookies. You can just guess easy ones with brute forcing. Rainbow tables, if you can get the hashes, we can see what's there. And then the most egregious one of all, where somebody was using base64 encoding when they should have been using encryption or hashing. We're not going to go through this full list, but this is a lot of what we were just talking about, these places that there's protective measures that prevent these type of attacks. Authentication has to be secure. It's one of the places that there's no room for error. There will be errors, and you need to catch as many of them as possible. Command injection. Command injection is where we're trying to send a command into the application that gets processed by the underlying operating system. That it's a command that gets honored, and here in this case, we're piping something in called file name. It's a parameter, and we're basically saying, go read this file. Then I use the semicolon to introduce a new command. So, and the way this is being read is it's running the command. So at this point, it's going to say, give me a file, and then, oh, by the way, here's your ID information. You know, this is the ID of who you're running as. PHP is notorious for this, but PHP is not alone. This is a really good example. So again, at the top, we have a vulnerable URL. And this is how we pass this in. And then the PHP, the underlying PHP, if is set, this get parameter, then I want you to echo and run the shell exec. So that's where we're vulnerable. Echo the name. So it's supposed to say the name and it's supposed to put in a temporary users file right here. But if I send in this information and then I say, oh, and also go grab me the Etsy password, then he'll process this and also pipe this information back up because of the echo that we're using. Input sanitization is not really a vulnerability, but it's important to talk about because it's ways of stopping injection. Once again, front-end security is a joke. This is an excellent example of front-end security. You want to make sure that users aren't able to change what they're doing in their applications and be able to easily bypass your security controls because in front end they can. It's super easy. Real quick, share with the developers. The main case that you want to share with them is use the don't repeat yourself methodology. If the developers aren't writing new code constantly and they're reusing the same code and they're all using the same code, chances are that code base, those functions that they're sharing are going to be more secure than the ones that are going to be one-offs. When I'm doing a pen test, I love finding one-offs because at that point, those are usually where the mistakes are made and usually where I'm able to put some sort of injection or take advantage of some functionality that was never intended. Deserialization, this is the act of taking like a JSON file or contents and then compacting it down to a nice, neat string of information, a long string, and this is a serial, and it needs to be sent. It's easier to send this information, and then it's easier to open this information. And these require parsers. So you have to have a deserialization parser. That's important that it needs to be there. And if the parser is vulnerable to, let's look at that bottom. So I'm sending some information in, and what I'm doing is I'm passing in a function. And my function's the DOS right here. And it's just the function name. And what he's saying is while true, nothing. So he's just going to say while true. And it's true. And that he's just going to keep doing it while it's true, meaning it's a function that never ends. And I can send this malicious serialized data to your parser and effectively DOS, denial of service, your entire application. Detailed messages, don't do this. Don't give me detailed error messages. Very important. Don't say anything, don't give me any details of what went wrong because I will use that against you. And if you're doing security testing, this is something you should always be looking at because you can look in here and you can have a better understanding. Like down at the bottom, we know that SQL is running because we can see SQL errors. We see SQL client errors, and we have a better understanding. We can make sense of the stack trace and understand what went wrong. What you do want to do is, if you're a developer, is you want to respond with a non-committal message. One, the message will respond with a 200, HTTP 200, saying, well, I caught it. I see there's a problem, and I'm not going to give it any indication that there's something wrong, other than something broke. I'm not going to tell you what it is. Move along. So the body of the email, I'm sorry, the body of the request and the response will indicate if what was in there, and sometimes also the headers, the headers of the request response will indicate what the problem was. And you want those to be as nondescript as possible. Give me a 200 and give me a generic message, and at that point you'll frustrate me as the tester, and we'll be able to move forward. Detailed messages, like we said, you should, if the developer should be lying to me as much as possible. So everything's fine. We talk about hidden resources with GoBuster, with DearBuster. These are things that are common vulnerabilities you need to be going and looking at. There's common files on the server, like robots.txt. You should go look at it. There may be some valuable information. There might be sitemaps. Go look at the sitemaps. It'll give you a much better idea of what's on the server. And when you're doing these hidden resources, just because it's listening on Git and it may not respond on every input, you can also switch your verbs to maybe use host or maybe change your user agents and see if it responds differently as you're trying to enumerate all these hidden resources. Definitely frustrate them as much as possible. With hidden resources, if you start getting, as a pen tester, if you start getting wildcard responses, you should probably give up because the service, anything you ask for, the server's saying, yeah, I've got that. I got you. No worries. And in that case, you're not going to get any valuable information, and you should probably move on. Host header poisoning. So this is a spot where we can actually tell the application, hey, I'm going to connect to you, and I'm going to change the host. So in this case, if you look on line 6, host is set to attacker.com. If the server doesn't check for that and doesn't make any verification of which host you're coming in at, then there may be a spot in the application that will benefit from that by taking the host and slapping it on top of a script that they want you to go get. In reality, I'm able to create my own and send you to my evil.com script and have you connect to me instead of where you were supposed to connect to. Host headers headers in general can also be attacked. If you can control the headers, then you can do some interesting things such as creating redirects. There's a lot of attacks that can happen at the header level. So you want to make sure, as a pen tester, check and see anything I'm doing is reflecting into the header. And as a developer, you make damn sure I can't affect the header. Because if I can add things in there and do all kinds of funny things. We talked about parameter pollution. This is where, in this case, you see we're searching Yahoo, and we're actually coming in 3 different times. One, P equals web, P equals application, and P equals security. How is the application going to respond to that? What is it going to do when it sees that? Which one is it going to honor? Are there security checks at different points? Does web get the security check, but application's the last one in, so it's the one that's actually processed by the functions? You will see this. The ACL will process, or the control will process on the first parameter, and then the last parameter is the one that's actually input without any security verification. Insecure direct object references, and guys, we're running, we've got about 5 more minutes. We're gonna work as fast as we can. These are classic cases of once you're authenticated as Bob, can you access Sally's stuff? Can Sally access your stuff? Can you access the admin stuff? You know, if the ACLs aren't working correctly, you can move around the applications because of poor authorization and access controls that should have been in place. We're going to skip the compare. It's an excellent tool in Burp that allows you to compare requests and responses to see if there's interesting bits. Local file inclusion is the act of going to a server and it says, oh, I'm going to read this other page and tell you what's there. Well, can you modify that and load something that doesn't belong there? So local file inclusion allows you to read information that's on a system. And here's a quick example where we say get the language, and in that get language, it's getting included. And in the inclusion, the word inclusion means that it gets pulled into the programming language, the file with the actual code, and is executed. That's the important piece. If it's not executed, then it's a different type of attack. But you can write code that gets executed on servers with local file inclusion. This one has its sister vulnerability of remote file inclusion. Instead of pulling from the local system, now you're going to pull from me. I'm going to stand up evil.com and I'm going to attack you and set up some scripts or set up some PHP, ASP items that I'm hoping you're going to read and that you process on your server, and I'm coming straight on into your application. Path traversal. So the .. is a fun way to be able to access, move around in somebody's server. This is becoming less of an issue over time, but it's still an issue you'll find on older systems. Race conditions. This is when I'm on a banking site and I have $1,000 in my site and I transfer out $1,000. Well, what happens if I send the request twice at the exact same time? You know, it's like, bam, bam, I'm going to send this. Well, what the server is supposed to do is it's supposed to say, do you have $1,000? Yes. Lock it, then send out the $1,000. But what happens if both these requests get there, they do the check, do I have $1,000, and they start sending it before the lock hits? This is an important thing that you need to be aware. Race conditions can be taken advantage of, where we can force functionality that was not intended, and I can overdraw this account or steal money from your account because we got away with a race condition. Not race condition, who's there? So it's an easy way to understand. SQL injection. This is my talk in 10 minutes. So as I'm filling for this one, we're going to do we're going to do SQLnet. Old joke from last year. But SQL injection, we're going to go really in depth here. I've updated the information quite a bit. I've got some really exciting pieces to share with you. Server-side request forgery is the piece that looks like local file inclusion. It feels like it because you're telling the server to go get something. But the only difference here is that the server does not execute what it retrieves for you. The server will go get things for you, but the server won't execute it. That's an important concept. It will retrieve it. It may not even show it to you. It may show it to you, who knows, but it won't execute it as code. But this is the case if I find a server on an internal network, you know, he's part of the DMZ, and I can tell him, go get this file on the internal network. He'll try and go get it and bring it back if he can. And this is where we can force the server to do behavior that the server was not intended to do. Server side template injection. We're going to be really brief here. It's a way of templating your data into your applications, and sometimes we can take advantage of that, and we can do some really cool things. I would love to talk more about this one, but I want to jump past this one. This is a place where we can take advantage of poor evaluations and add in, like here we say, oh, by the way, I want you to run a command, so the ID command. So, but it's all template injection, XML, external entity, XXE. So we're almost out of time. The XXE attack is basically a server-side request forgery, where we send a vulnerable, a malicious XML file to a vulnerable XML parser. This problem was fixed several years ago, but you'll still see some old parsers. People don't like writing parsers. I don't blame them. I don't like writing parsers. Where you'll send a vulnerable XML file that has this script tag, this entity tag right here. And this entity tag will say XXE, go get this system file, or go get another file on the network. And you can test for this. You can send these files and see if they're going to retrieve that and bring that back. Once again, they don't execute it, but it's an XML way of grabbing this information. Always check for the third-party libraries. See, NPM is full of really vulnerable libraries. Here's us just looking at Batman that hasn't been updated, and these are just silly libraries that can probably be taken advantage of. And I'm going to end it right there. There are some other ones I really wanted to cover, but we're out of time. We have client-side attack vectors. I would love to take this offline with you guys. You guys can reach out to me in Slack, and you can also reach out to me the Twitter handle that I put at the beginning. Cross-site Kris, definitely reach out to me, and I always welcome any questions. James, did we have any questions before we? No, we're good. Okay, all right, you guys enjoy, and thanks for having me.
All right, thank you so much, Kris. And he's actually given 2 talks today, and I believe your next talk is in track 1. So if you want to follow along Kris's journey of web applications and attacking them, track 1, he's going to be talking about SQL injection on steroids, going deep. But in track 2, we actually have one of our gracious sponsors. That's, I believe, Alias has been there since the very first year, and really good friends of mine. They've been building out the community. They've actually taken a lot of their funds, I would like to say, and actually taken it out and actually created smaller conferences in areas that don't usually get that kind of, I guess, recognition or any kind of information as information security goes. And on their own dime, going out and trying to actually just spread the good word and trying to get people more involved and hopefully a better level of understanding information security. And so Alias Forensics has been a great community leader in that. And it's always a pleasure to have them around. And Andrew, the stage is now yours.
Thank you, Jimmy, for the kind words. I really appreciate that intro. Going to be a little tough to follow, but hey, I think we got it, man. Yeah, so like he said, I'm Andrew Nolan with Alias, coming to you live from the Secure AF studio, where we record our podcasts and videos and all that fun content we've been working on here the last year. Wanted to definitely give a big shout out to the other sponsors, the presenters, and all the volunteers who made this happen. I've had a lot of fun just chatting on the Slack channel today, and the turnout's been incredible. So thank you guys so much for doing that. So a little bit about Alias. You may recall us always being Alias Forensics. So with all the conferences being canceled earlier this year, we decided to put our marketing creative director, Teddy, to work on doing a rebrand for us. We're busting into some new markets. We just opened a new office down in Las Colinas so that we can help serve the DFW area a little more effectively. And so she's done a great job on that, dropping the forensics, but we're still going to be offering those types of services. Still do data recovery, still do expert witness. We do forensic collections, all that for court and commercial litigation, but incident response as well. but we definitely want to put our focus on doing cybersecurity consulting. I think you ask anybody in Oklahoma, they'll tell you, what does Alias Forensics do? Well, they do pen testing. So we're trying to, get that message a little more unified for the new markets going forward. So along with pen testing, we're doing a lot of cybersecurity consulting, gap analysis for different compliance regulations, whether that's PCI, you're wanting to meet a certain standard with NIST, or a lot of the DoD contractors are having this new thing called CMMC come up that we can help provide, where you stand currently, where you need to get for those types of audits. And there's a lot of services we offer that help you get there as well. So please reach out to us about that. I myself have been personally following it since the end of 2019, and we're very involved with some of the individuals who helped develop that framework. So if you need an assessment, we could definitely get you in the right direction for that. We always have offered secure monitoring services for small to medium-sized businesses, security engineers as you need for contracting. As far as tools that we have, we do have our own SIM, we do have our own intrusion detection system and intrusion prevention system, but we definitely want to, get out there and help you guys make the right decision on, what type of tools and controls you can be putting in place to make sure that you're getting where you need to go. One of the big things about the rebrand, and I thought this was pretty good with Teddy, was, Domino's dropped pizza. They do other things than pizza. Dunkin' dropped donuts. You can get other things than donuts there now. And so for Alias going forward, we want to kind of have that same flexibility to make sure that we could serve our clients just, as well as we could. So please, if you have some time, go check out the new website. That's aliasinfosec.com. If you go to aliasforensics.com, you'll still be routed there. But, it's something we're very, very proud of. Again, Teddy's worked super hard on this. So definitely go check that out for him. If you want to catch up with us, want to talk about something specific, jump on Slack. I and Teddy both will be, harassing people throughout the day. So please come give us a chat. Love to catch up with everybody. Good seeing everybody on there, and hope everybody enjoys the rest of the conference. Y'all take care, okay?
Thank you so much, Andrew. I really appreciate you,
Thank
your time and everything. And again, once again, your support this year. And I'm so excited to see what y'all are dreaming up for this next year. And of course, look forward to talk with you later. And so thank you again, Andrew.
Absolutely, man. Thank you guys.